So I'll go over some of the items in Snowplow-ROS. So this first ROS module is the custom message, and it's quite simple. It's related to obstacle detection. So using the camera, we want to know if something is in front of the robot. And so this message is it's just blocked, and it's a Boolean. So either the robot is blocked or not blocked. So it's fairly simple. And so that will be sent by the obstacle detection, and then anybody else can read it in order to do navigation. And so the next part related to that is the vision module. And so it has a single Python class here called obstacle detection. So yeah, if I go to the bottom here, you can see that it's going to initialize. It's going to create the object, and then it's going to call run. So it's three things. So let's look at the initialization first. So here it's setting up the publisher. That's going to publish that message that I just showed earlier. So it's the obstacle status publisher. And then it's going to initialize some default values. This is related, so right here, this is related to the camera. So default values being like the name of the camera, how many frames per second, and the obstacle threshold. And then finally, it initializes the values. So here it's doing the initialization. So ROS has like a global store of parameters. So here there's a parameter called OAVG camera. And so we're retrieving that, and if it's not found, then we'll use the default value. So if this doesn't exist in the global store, we'll just use this value. That's what's happening here. And then this is whether the camera is flipped or not. So sometimes the image is upside down, so you want to flip the camera, the number of seconds, and the threshold. So the threshold in this case is, so when we're detecting the obstacle, it's like a number between 0 and 1. So the threshold is just how confident we want it to be to identify an obstacle. So then at this point, it's going to read in the model, the machine learning model, and the labels that are used for in order to do the obstacle detection. And it's doing some. So it reads them in, and then it checks to see if these files exist. And if the files don't exist, it's suggesting that you have to run this. So this is a ROS command that cat can make, builds the whole system. But there's a target here called download extra data. And that will go off and download the machine learning model and put it in a known location. And this is necessary. Well, it's not necessary, but this way we avoid storing the model in the repository. It can be stored outside. Okay, and then after all that setup is done, then the run begins. And there's some more setup here for the model and the labels and the just some details. And then the rate, which is defaults to 2 frames per second. Then we're getting the camera, and then we open the camera, and then in this loop, while the camera is streaming, we capture an image. We call the classifier. So this obstacle status is that the queue that we're gonna, or the publishing queue that we're gonna send the message to. And so by default we say it's false, but if we detected that it was blocked, then we set block to true, and then we publish. We do a sleep, and basically we do it again until so it does it until the camera isn't streaming anymore, or ROS is shut down, or possibly some exception occurs, and then it's closed. Okay. And so I'm not going to describe the code, but there's these other 3 modules. I'll just give a bit of an overview. Bring up is kind of a ROS default name for a module that has scripts to start a robot. And currently, we just have what script to launch the JetBot. But you could imagine we could have more scripts here, perhaps to launch the simulator or some other non-JetBot platforms. The description is it's the gazebo description of our robot. So like the 3D model description, that's all stored here. And then the gazebo contains like a virtual world for the gazebo simulator, along with some scripts that we use to interact with the virtual world. And here is right at the top in this README, there's pretty good step-by-step instructions to run the simulator. All right, that's everything I have related to the Snowplow-ROS.